Algebra 2, Chapter 7.2, exercises 12 through 22. In this exercise set, we're going to work with multiplying polynomials, specifically verifying and using identities. And in keeping with the tradition in my videos of working out the odd number problems, I'm not going to start here at working out the entirety of problem 12. But I'll just kind of show you how I would approach problem 12. What I would do is I would take this quantity x plus y plus z squared and I would multiply it out using a box method. I just think that would be an easier way to go. Now you could, if you wanted to, take this quantity x plus y plus z, square it like this, and do the distribution like this: x to x, x to y, x to z, and then y to x, y to y, y to z, and finally take the z to x, z to y, z to z. You could do that. But I would probably, for organizational utility, set the thing up like this. Now that's just me. And I would set it up like this. I'd put x, y, z like this, and then x, y, z like this, multiply in each of the cells, and then combine like terms to get, you hope, this is your final answer. Okay, now the ones I'm actually going to start working out, starting with problem 13. What I'm going to do is we have the simpler identity on the left, and what I'm going to do is distribute all this on the right, and after all the cancellations we should end up with a to the fifth power plus b to the fifth power. And I'm going to take my own advice from my last problem and working out a box. And here we have a binomial times a polynomial with 1, 2, 3, 4, 5 terms. So that's going to be a 5 by 2 box. Well, to do that, I'm going to have to make a nice long one like this. So this is going to be my 5 by 2 box. Here's my 2 in the rows and the 5s. That's a lot of cells. 1, 2, 3, 4, 5. Okay, and then we have my binomial. Our binomial is going to be on the left, a plus b. And then here, our 5-term polynomial. We're going to have a to the 4th power. And we're going to have negative a to the 3rd b. We're going to have a squared b squared, we're going to have negative ab cubed, and then we're going to have finally b to the 4th power. And so we just multiply where these rows and columns intersect. So a times a to the 4th power is going to be a to the 5th power. And then we're going to have a times negative a cubed b is going to be negative a to the 4th b. And then a times a cubed b squared is going to be a squared b squared. A times a squared b squared would be a cubed b squared. Then we have a times negative ab cubed is going to be negative a squared b cubed. And finally we're going to have a times b to the fourth power. And then we're going to have a to the fourth power times b, so a to the fourth power b, and then b times negative a cubed b is going to be negative a cubed b squared, and then b times a squared b squared is going to be a squared b cubed, and finally, not finally, but b times negative a b cubed is going to be negative a b to the fourth power, and finally b times b to the fourth power is b to the fifth power. And if we take these, combine these terms diagonally, we have a to the fourth b minus a to the fourth b will cancel each other. And likewise, these two terms that I am now encircling will cancel each other. And these two terms here, a squared b cubed minus a squared b cubed, they will cancel each other. And finally, negative a b to the fourth power plus a b to the fourth power will cancel each other. So all these encircled pairs of terms will cancel each other, and we are going to be left with simply a to the fifth power plus b to the fifth power. So that's going to be our verification of this identity. Next, we'll go to the odd number problem 15. We have quantity a squared b squared times quantity x squared y squared is equal to this on the right. Now you notice on the left we don't have any negative signs, and so what we're going to do is expand our expression on the right side of this equation to, we hope, distill the results to end up with the left side of the equation. So what I'm going to do for this is similar to the way we've done these other problems so far. I'm going to take this first one here. I'm going to put, we have quantity ax minus by squared, so I'm going to put ax minus by. Over here, ax minus by. And I'm going to similarly take the next binomial squared, which is going to be quantity bx plus ay. And then, so let's just work these out. Ax times ax is going to be a squared x squared. And then we're going to have ax times negative by is going to be, just have all these letters together, we're going to have negative ax by. And then we're going to have negative by times ax is going to be negative ax by. And then finally we'll have negative by times negative by is going to be b squared y squared. Now next, in this second box, we're going to have bx times bx is going to be b squared x squared. And then we're going to have, on the upper right cell, we're going to have ax by. And then we're going to have, on the lower left cell, ax by. And then in the lower right cell, we're going to have a squared y squared. And we're going to take all these terms and add them together. And I'm going to take these over here to the left. I'm just going to write them out. We have a squared x squared minus ax by minus ax by, and then we're going to have plus b squared y squared. And right underneath what I'm going to do is take, I'm just going to write this, the bottom problem there, I'm going to put right underneath it, we're going to add to that b squared x squared, and we're going to put plus ax by plus ax by, and then finally plus a squared y squared. And when we create a sum of all these, you notice that our minus axby plus axby, these will cancel each other. Negative axby plus axby will cancel each other. So what we're left with is a squared x squared plus b squared x squared plus b squared y squared plus a squared y squared. Alright? And so, working backwards from that, we will show you what's going on here. Now I'm going to use the 2x2 box for the purposes of factoring. So I'm going to put this on the upper left, I'm going to put this a squared x squared here. Over here on the upper right, I'm going to put, let's see, where do I want to do that? I'm going to put the b squared x squared down here. So this one's going to go here. The b squared x squared I'm going to put right over here. So b squared x squared. And then over here, I'm going to place our a squared y squared here. And then down the lower right, I'm going to place the b squared y squared. And so what we have here is up above, what is a squared x squared? Well, it's going to be the product of a squared, which I'm writing outside on the left, and x squared up above. And on the upper right, what are we going to have? Well, a squared y squared is going to be the product of a squared and y squared. And then here on the left, the bottom row, what is going to be b squared x squared? It's going to be the product of b squared and x squared. So now what we've done is we've distilled and demonstrated what we have left is quantity x squared plus y squared times quantity a squared plus b squared. Now, I wrote them in a different order than the original left side of the equation, but because of the commutative property of algebra, this is an equivalent expression. Let's go on to the next set. Next set of problems, I evaluate the following polynomials using one or more of these identities. And so there's going to be problems 16, 17, 18, 19, 20, and 21. And keeping with tradition, I'm going to work out these odd problems. And I think that they coincidentally are going to be able to use each of these identities. So here we have problem 17, which is a square which is 32 squared. And what we're going to do is use this first identity in this manner. Here we're getting into binomial expansion. And what we're going to do is we have this quantity x plus y squared equals x squared plus 2xy plus y squared. So for this one, I'm going to say let x equal 30 and let y equal 2. Okay, so we're going to say, so for this, using the identity, we're going to say, we'll rewrite 32 squared as, we'll have 30 plus 2 squared is going to be equal to the first term, which we're going to call x. So that's going to be, what I'm going to do for this is write the identity, if I can do that. Let me see if I can do that. I'll put the identity right above it for clarity's sake. I'm going to put right above here quantity x plus y squared equals x squared plus 2xy plus y squared. So what we're going to have is this 30 is going to take the place of the x. We're going to have 30 squared plus 2xy. So that's going to be 2 times 2 times 30. I'm just going to put it like this, 2 times 2 times 30 plus y squared. That's going to be 2 squared. And this is going to be equal to 30 squared is 900. And 2 times 2 times 30, well, that's going to be 4 times 30. So that's going to be plus 120. And then 2 squared is 4. So we're going to have 900 plus 120. That's going to be 1020. And 1020 plus 4 is going to be 1024. So that is going to be our answer, our evaluation using this identity. Now the next odd number problem here I'm going to work out is 19. And for this, we're going to take this identity, which was x squared, our quantity x, minus y squared is equal to x squared minus 2xy plus y squared. Let me make sure that's right. Yeah, it's this last one here. Okay, let's do that. And so we're going to say let x equal 50 and y is equal to 3. And doing that, we're going to rewrite this as 50 minus 3, 50 minus 3 squared is equal to 50 squared minus 2 times 50 times 3 plus y squared, so that's going to be plus 3 squared. And just working below, 50 squared is going to be 2,500. 2 times 50 times 3, well, 2 times 50 is minus 2 times 50, that's 100 times 3, so that's going to be 300. And plus 3 squared is going to be plus 9. And so 2,500 minus 300, that's 2,200, plus 9 is going to be 2,209. Okay, so that's going to be using that particular identity. And the last one here, 21, I'm going to do in this set is we're going to use this other yet unused identity, which is the difference of squares, this second one right here. So let's go over here. We're going to say x squared minus y squared is equal to quantity x plus y times quantity x minus y. And for this particular one, we're going to have our x be the average of these two, 58 and 68. They are 10 apart. And so the average, we're going to say let x equal the average of these two numbers, which is 53. And we're going to say let y equal 5. And so what that's going to be is it's going to be x plus 5, x minus 5. So we're going to go ahead and write this out as, this time I'm going to work this out on the right side. So we're going to have x, that's going to be 53 plus 5. And I hope you can see that that's 58 times quantity. Oops. I said 53. It's going to be 63. There we go. Times quantity 63 minus 5. And what that is going to be equal to is this right here on the left is going to be quantity 63 squared minus, or 63 squared minus 5 squared. Now, the problem I have is that 63 squared doesn't readily come to mind, but I know that using that first identity, this is going to be equal to 63 squared is going to be equal to 60 squared plus 2 times 3 times 60 plus 3 squared. So that's going to be equal to 3,600. And 2 times 3 is going to be 6. 6 times 60, that's going to be 360 plus 9. So 3,600 plus 360, that's going to be 3,969. So what we're going to have is, now coming back here, we're going to have this be 3,969 minus 5 squared, which is 25. And so that's going to be 39. And you subtract 25 from 69. 6 minus 2 is going to be 4. And 9 minus 5 is 4. So this should be our answer right here. And I'm going to check using a calculator. So it should be 58 times 68 should be 3944. Please be 3944. There it is. It checks out. So those are all the odd number problems worked out in this set. We'll just take a glance over here at problem 22 so you can see it. So here's the problem to evaluate which of these students made an error in the different expansions. Let's see, which one's it going to be? Yeah, it's not going to be. I think the right one is on the left. Anyway, that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.